In this episode, we are going to learn how to use GLSL shaders in Arcade. So the end result, what we are going to create, will be something like this. So we will create a gradient shader, so some kind of a sky shader. So it will start with blue and it will fade to green. So this can be a background for our platformer game we created a few videos earlier. Okay, first let's go to the documentation. And here, if you click on the API reference and API reference again, just search for the OpenGL. So not for the OpenGL context, but just OpenGL. And here you will find the shader/program. And as you can see, you can create multiple shaders. What we are going to create is a vertex shader and a fragment shader. But you can also create a geometry shader, a tessellation control shader, a tessellation evaluation shader, and I think you can also create compute shaders in Arcade. Let's search for shader here in the search, and as you can see here is an example for a compute shader. So if you want to use or create compute shaders, you can also do it in Arcade. I will not do it because this is a pretty advanced stuff. So let's go back to our scene, and the gradient shader I'm going to add to this simple platformer as a background. So now we have just this black background. Okay, so let's do it. Okay, I'm going to create the shader in the game view class, and here in the init method. After we create here the music and the sound, I'm just going to add the geometry for the shader. So this will be the gradient shader, and this line creates a GL geometry that will be used to pass pixel coordinates to the shader, and it has the same dimensions as the screen. And you can create this using the arcade.gl.geometry.quad2dfs, and I think fs stands for full screen. Let me search for this function in the documentation. So quad2dfs, and here it is, and creates a screen aligned quad using normalized device coordinates. Okay, so let's go back to the code. We have the geometry. Now we should create the two shaders, the vertex shader and also the fragment shader. So cell.program equals cell.window.context or ctx.program, and this needs the GLSL shaders. So what we are going to create is the vertex shader and the fragment shader. And as you can see, here are the other types, so geometry, tessellation control, tessellation evaluation, and some other parameters. Okay, let's do first the vertex shader, and this has to be a Python multi-line string. And here, of course, you have to know a little bit of GLSL programming. I'm going to use GLSL version 330, so I'm just going to add here the version specifier, so hashtag version 330, and after that I'm going to create an input vector, so input of type vector2, and this is the input underscore vert, or the input vertices. And after that I'm just going to create the main function. So, and the main function in GLSL will run for every vertex, and in the body of the main function I'm just going to set the built-in GL position value to vector4, and as an XY parameter I'm just going to add the input vertices, and the Z parameter will be set to 0 and the W parameter will be set to 1. So that's all what we have to do in the vertex shader. Now let's do the fragment shader. So as a second parameter for this context.program function, I'm just going to add the fragment shader and also a Python multi-line string, and also add a version specifier, which is of course version 330, and this is GLSL version 330 is the same as OpenGL version 330. And also going to create an output vector, so out of type vector 4, and it is called fragment color. And the fragment shader runs for every pixel. Vertex shader runs for every vertex, and the fragment shader runs for every pixels. Also going to create a uniform, so uniform of type vector 2 called resolution. And the uniform variables are useful when you want to pass values from the front-end program, so from Python, to the backend program, so to GLSL. And the GLSL program runs on the GPU. And we should also create a main function, so void main. And here we are just going to create a simple calculation. So I'm just going to create here a vector 2 called position. So this is the type vector 2, and this is the variable name, so position. And we are going to use the glfrag coordinates .xy, and this is called swizzling in GLSL, so you can access the xy value like this. And we are going to divide this by the resolution .xy. So it will divide element wise. glfragcord.x will be divided by the resolution.x, and the glfragcord.y will be divided by the resolution.y. And also set the glfrag color. So this is also built-in GLSL variable. So gl_frag color will be equal to vector 4 and red, green, blue and alpha values. So 0.3, 0.5. Here we are going to set position.y, and alpha value will be set to 1. So this is a very simple fragment shader which will create for us the gradient, the linear gradient. And the next thing what we have to do is set this resolution variable from the Python. And the resolution will be, of course, the window's width and window's height. And you can set the resolution, so these uniforms, like this. So cell.program, so the program is this. Cell.program, and you can set it as a value in a dictionary. So here we are selecting the resolution, and we are setting its value to cell.width and cell.height. And this is the window's width and the window's height, so 1280 by 720. So this is how we can create a simple GLSL program in Arcade, and in order to draw it, you have to go inside the onDraw function. After the clear, so we are clearing the color buffer and the depth buffer. Here we are just going to draw the cell.quadfs, render and cell.program. And the quadfs is what we have created here using the Arcade GL Geometry Quad 2D-fs. And also passing to it the GLSL program. And now if I run this, as you can see, we have a very nice background, sky background. So it starts with blue and it fades into green. So this should be, you can also draw some kind of clouds here and some kind of grass here, and this will look very nice in a 2D game. Okay, probably I'm just going to create one more video about GLSL programming, because I also want to add some vignetting effect to this game.